On this one, we're going to have to talk about this a little bit more before we actually start it, because these functions are in the wrong notation. So whenever our function is f of x equals, and then we have our function over here, let's say it's x squared plus 9, we know the variable in the question is the variable x, and that f of x is really our y value. Well, now if you take a look at this, it says f of y is equal to 3 minus y squared, which means the variable in question is the letter y, which means that this cannot be y. This would have to be our x, which basically means that they are giving us the inverse function. Well, you can't type this in your calculator right now because there's a letter y here. So in order to graph it in your graphing calculator, you're going to have to rewrite. So you're going to take your x equals 3 minus y squared, and you're going to have to solve for y now. So that become x minus 3 is equal to negative y squared. Positive y squared then would be negative x plus 3. Then you would square root both sides, and you would get positive or negative square root of all of this. Now you can type this into your calculator, but the way you type in your calculator is you'd have to do y1 would be the positive square root side. Y2 would be the negative of the square root, and that together will give you the full graph of plus or minus. All right, let's look at the other one. The other one's actually quite easy to deal with. So that'd be x equals y plus 1. So if I asked you to solve for y, remember you would just move this 1 to the other side. So then the other function we would let be y3, and that would be y is equal to x minus 1. So now take a few minutes and get these on the graphing calculator so you can see what the graph even looks like. So these are, again, harder to graph because you have to do some manipulation first so you can even type it into the calculator. Okay, so after you've typed those three functions in your graphing calculator, it should look something like this. So what is the area shaded or bounded by this curve here and this straight line here? Well, it would be this section right here. So I'm going to write this off to the side because I want to get it out of my way. So normally we go with the top higher level curve and we subtract the bottom, and that's when everything is given to us in using the x variable. And then we have x limits here, and our x limits are the very left side of the point of intersection and the very right side. But now when you throw in a twist like this and everything is based on a y variable, everything gets turned on us. So when there's y variables involved, we still are going to take the integral, but instead of saying top minus bottom, we're going to go right minus left. And this limit down here is a y value, and this limit down here is a y value because the limit, or the variable here is a y. This variable here would be the very bottom of all the point of intersections, and this would be the very top. So you got to kind of keep in mind that if they give you the functions kind of out of the ordinary, and they give it to you in terms of y instead of terms of x, we actually have to kind of reverse the process here and deal with it this way. So now what we're going to do is we're going to take the integral. Now if we look closely over here, which one is the very right function? Okay, that was our first function right here. So we're going to go 3 minus y squared minus, and then our other function here was our y plus 1. And now these are our y limits. The y limit, point of intersection at the bottom, I need to find that. And up here I need to find that. Well, let's step back for a second. A couple of problems back, we talked about how to find points of intersection if this was a non-calculator problem. So we off to the side have to set our functions equal to each other. Okay, so this is a quadratic, so now we want everything on one side, so we're going to move this over. And we're going to move that 3 over. So we're going to go ahead and factor. Okay, what numbers will multiply to give you negative 2 and add up to 1? That would be 2 and negative 1. And then we'll set each one of these equal to 0 and solve individually. So our points of intersection are negative 2 and 1. The lower one goes here, negative 2, all the way up to a 1, which that would be the lowercase one here. They're meeting at negative 2, and up here they're meeting at a y value of 1. We're going to go ahead and simplify. So we have a negative y squared, a minus y, and we have 3 minus 1. Okay, we're going to take the integral. Alright, so let's plug a 1 in everywhere we see a y. So if I plug it in there, that would give me negative 1/3 minus 1/2 plus 2. Okay, minus, now let's plug in a negative 2 wherever we see a y. Well, a negative 2 cubed would be negative 8, but then there's another negative sign. That will give me positive 8/3. Negative 2 squared is positive 4, but there's a negative sign there, so it would be negative 4 divided by 2. Plug in a negative 2 there. Alright, so let's get a common denominator here. We can get a common denominator, everything can be over 6. Negative 1/3 is the same as saying what over 6? That would be negative 2/6. Negative half is the same as negative 3/6. And then this would be 12. Okay, common denominator with this common denominator, I'm still leave it a 6. It makes it easier. So if I go ahead and fix 8/3 is something over 6, that would be 16/6. This here would be 12. And then this one would be 24. Alright, so let's go ahead and add up what we have here. We have negative 5 and 12, so that makes 7/6. 16 minus 12 minus 24, that would give me negative 36, and 16, that would give me 20. That would give me 7 minus negative 20, so really it's 7 plus 20. Final answer is 9/2.